Welcome to SAT 021. The topic of this lesson is linear inequality. A statement with an inequality symbol placed between two expressions is called an inequality. And there are four commonly used inequality symbols. The first one is less than. It looks like an arrow pointing to the left and opening to the right. All right. Look at the example. So 1 plus 3 is 4, and 4 is less than 5. The second one, less than or equal to. So there is a bar down there representing equal to. And look at the example, 6 minus 1 is 5, and 5 is less than or equal to 5. The third one, greater than, is greater than. The direction of greater than is the opposite of that of the less than symbol, right? And look at example, 2 times 4 is 8, and 10 is greater than 8. The fourth one, greater than or equal to. Okay, there's a bar down there representing equal. And the example, 9 minus 1 is 8, and 10 is greater than or equal to 8. The set of points on a number line that represent all of the solutions to an inequality in one variable is called the graph of the inequality. So let's look at two examples. The first one, x is less than 1. So draw a number line. We find the origin and then all these scales. So x is less than 1. That means 1 is not included. Okay, so 1 is not part of the solution. So we're going to draw an open circle. That means 1 is not a solution. And then x is less than 1. Okay, meaning numbers smaller than 1 are solutions. So we're going to draw an arrow pointing to the left. Okay, the second example, x is greater than or equals to negative 2. Okay, so we locate negative 2, and since there is a bar down there, meaning equal to, so that means x equals negative 2 is a solution. So we need to draw a closed circle, including negative 2. And then x is greater than or equal to negative 2, so we are looking at numbers bigger, okay, greater than negative 2. So including negative 2. So draw an arrow pointing to the right. To solve inequalities, we need to create equivalent inequalities. Okay, so for example, 2 is greater than negative 3. To represent this inequality on a number line, okay, so we can find negative 3 on the left side and the 2 on the right side. Okay, but if we add a 2 to each side of this inequality, okay, it's the same thing as moving negative 3 and 2 on the number line 2 units to the right each. Okay, so negative 3 move 2 units to the right, we get negative 1, and 2 move 2 units to the right, we get 4. And the resulting inequality, 4 is greater than negative 1, is still true. Okay, so that means if we add the same number to each side of this inequality, the resulting inequality is still true. Okay, so let's give us some properties of inequalities. If A is greater than B, then A plus C is greater than B plus C, and A minus C is greater than B minus C. Okay, so we use the same example, 2 is greater than negative 3. If we subtract the same number 2 here, we will get 0 is greater than negative 5, which is still true. Okay, the second one, if A is greater than B, and if C is greater than 0, then A times C is greater than B times C, and A divided by C is greater than B divided by C. Okay, so same example. So if we multiply the same number, positive 2, to each side of this inequality, and then we'll get 4 is greater than negative 6. It's still true. Okay, the third scenario, if A is greater than B, and if C is less than 0, that means C is a negative number, then A times C is less than B times C, and A divided by C is less than B divided by C. Okay, so here we need to switch the direction of this inequality. Okay, so let's still look at an example. The 2 is greater than negative 3, same example. So if we divide negative 2, Okay, C here is -2, and it's less than 0, right? It's negative to each side of this inequality. So the left side, we will get -1, and the right side will get positive 1.5. So it's not greater than anymore. We need to switch the direction of this inequality, and it turns into less than. So -1 is less than 1.5. Okay, so this is extremely important. Okay, so when we multiply or divide a negative number to each side of an inequality, we need to switch the direction of the inequality symbol. Okay, so to summarize, if we add or subtract the same number, or if we multiply or divide a positive number, then the direction of the inequality symbol does not change. And as I mentioned earlier, if we multiply or divide the same negative number to each side of this inequality, then the direction of the inequality sign must change. Okay, and these properties apply to greater than or equal to, less than or equal to as well. So let's look at a practice question. Which of the following inequalities is equivalent to the inequality -6x minus 12y is less than 3? And there are A, B, C, D, 4 choices. And when we look at the 4 choices, we realize the coefficient of x is 2, all of them, right? So 2x, 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 2x. Then how do we get the coefficient 2x from the -6x in the given inequality? And we realize -6 divided by -3 will get 2. So we're going to divide each side of this inequality by -3. And remember, when we multiply or divide a negative number to each side of an inequality, we need to switch, we need to change the direction of the inequality. So it was less than, now it turns into greater than. Okay, and then we simplify. So we get 2x plus 4y is greater than -1. So that will be D. Okay, so divide by -3 to each side, switch the direction of the inequality symbol. Let's look at another practice question. Henry has a budget of $600 in cash for buying new electronics. He is not allowed to spend more than the $600 given. He has spent $200 on a cell phone, $40 on wireless earphones. He is still looking at getting a new tablet with trading in his old one. If the trade-in value of his old tablet is $70, write an inequality to represent the price of the new tablet he can afford without overspending. Okay, so he has $600 in total, and he is not allowed to spend more than 600. Okay, so that's less than or equal to 600. Then he spent $200 on a cell phone already, $40 on wireless earphones. Okay, so that's spent. And he is still looking at a new tablet. Let's say X is the price of the new tablet. Now, he can trade in his old one, and that $70 can be deducted from the price of his new tablet. Okay, so the actual money he will pay for the new tablet will be X minus 70. Okay, so that's the inequality we are looking at. If we have to simplify, and then we will solve and find the price of the new tablet cannot be more than $430. Okay, so that's all for this lesson. Thank you for watching. Goodbye.